Hey everyone, we're going to be taking a look at the AP Calculus B final. This video is questions 19 through 23, which are non-calculator questions. So you won't see any calculators being used in the computation of any of these. So starting with question 19, we have evaluate this antiderivative, and I'm taking a look at that and I see a lot of root functions, which are not that they're difficult, but it's easier to compute them if we look at them as rational exponents. So here we have our integral. I'm going to copy that again and begin to modify, starting with this root y, which is the same as y to the 1/2 power, which means we can take that out of the fraction and just make that first term 1/5 y to the 1/2 power. The second root y over here, we can also make that y to the 1/2 power. And we can even bring it to the numerator with a negative 1/2 power, which means it doesn't have to be in a ratio anymore. So now that this is simplified with rational exponents, we can apply the power rule to these really easily. Let's split up that integral. We move these coefficients to the outside of our integral. And then we can just apply the power rule. We've got y to the 1/2, and if we do 1/2 plus 1, that's 3/2. So y to the 3/2. And then we need to multiply also by the reciprocal of 3/2, which is 2/3. Over here, we've got y to the negative 1/2. Negative 1/2 plus 1 is 1/2. So we can find the antiderivative of y to the negative 1/2. That's just y to the 1/2 multiplied by the reciprocal of 1/2, which is 2. And then we'll add a constant of integration to the end of that. We'll copy that down and start simplifying. We got this 2/3 power here, which, I suppose we can put that together with the 1/5. And then 1/5 multiplied by 2/3. That's 2/15. Y to the 3/2 power. Well, you could think of that as y to the 3rd power to the 1/2 power. So just the square root of y cubed. On the back side of this, we've got the second term. It's not the back side, but we've got that 2. We can commute that to the front, and then we've got 2 times 3. I have it on good authority that that's just 6. And again, that y to the 1/2, that's just the square root of y. And yeah, I think that's going to be it. I'm pretty sure that's the way that it looks on the answer key. However, I do want to take it one step further because I can. So let's take out a 1/15. So if I take out a 1/15 out of this whole mess over here, I'm going to have to divide 2/15 divided by 1/15. And that's just 2. If you distribute that 1/15 in there, you can kind of see that 1/15 times 2 is just 2/15. We'd have to distribute it out of this 6's also. So 6 divided by 1/15 is the same thing as 6 times 15. So if we have 6 times 15, or 6 divided by 1/15 is 6 times 15. That's a 90. Okay, so that looks pretty good. Looks like I can factor out a 2 as well. Let's factor out a 2. This first term, that 2 divided by 2 is 1, so we don't need that 2 anymore. 90 divided by 2 is 45, so that's good. They also have a common factor of the square root of y. So let's factor out a square root y. So for this first term, I think that's the one that people have a little bit of difficulty with. We've got we have y to the 3/2 power, y to the 3/2 power, divided by y to the 1/2 power. And when we divide two exponents with the same base, we just need to subtract the powers. So 3/2 divided by 1/2 is, let me just illustrate that. That's y to the power of 3/2 minus 1/2. And that's the same thing as y to the first power. So we can change this to y to the first power right there. And then over here, we've got 45 y to the root y, or 45 root y. Yeah, that can simplify out. So here's another way you might see that. Sometimes you might see this root y over here. Put that on the numerator here. Sometimes you might see that. That's an alternate way of looking at question 19. So I think I've done this one to death. Let's move on to the next one, number 20. Here we go. It says to evaluate the integral 4x cubed multiplied by the cube of x to the 4th minus 1 dx, using that substitution where u is equal to x to the 4th minus 1. Okay, let's copy down our problem. Okay, here's our problem copied down. Let's make that substitution. So we're going to say u is going to equal to x to the 4th power minus 1. So every time I see x to the 4th power minus 1, I should be able to just substitute that freely with a u. So here's an x to the 4th minus 1 over here. Let's turn this into a u. It's u to the 3rd power. That looks pretty good. And then the next piece of this would be to look for, replace my dx. So let's replace our dx. If we accept the substitution, then we also must accept that du is going to be equal to 4x to the 3rd power multiplied by dx. Or, to put it another way, if I wanted to solve for dx, then I would say that dx is going to be equal to du divided by 4x to the 3rd power. All right, so we can make that substitution next. Just do a little bit of reconstruction so we can follow the trail a little bit better. This is where we left off. So next I'm going to substitute this dx with a du over 4x cubed. And then we're going to simplify. First thing is that this 4x cubed on the denominator here, this 4x cubed on the denominator, that's going to cancel out with this 4x cubed over here. Let's get rid of both of those. Okay. And, oh my gosh, that's actually all we need to do. Let's simplify that so that it looks like a integral. And look at that, that's just the same thing as u to the 3rd power du. We know what that antiderivative is. That's 1/4 u to the 4th power plus constant. And then as a last step, we're going to substitute our back for our u. So this u here is going to be replaced with the, what is that, x to the 4th power minus 1. And I think that's where we have it on our answer key. So we are good to go in this one. Let's take a look at 21. Here's another substitution problem. We want to integrate from UA to UB. And UA and UB refer to the upper and lower limit of our transformed integral. So I'm going to go ahead and start by copying this problem. All right, here's our integral. Let's copy that down, and let's think about our u substitution that we need to make. It doesn't explicitly tell us what to do, but I notice that here on the denominator, if I just let u be equal to 1 plus theta cubed, my derivative there is going to be 3 theta squared. And conveniently enough, 3 theta squared is also part of the numerator. Don't worry about that square root. If I make this substitution, it's just going to be the square root of u. So that actually works really nicely. So here's our here's going to be our substitution. We've got 1. We're going to say u is going to be equal to 1 plus theta cubed. So that gives us a couple of things. That gives us that du is going to be 3 theta squared multiplied by d theta. Okay, so now we can make our substitution pretty clearly. Let's put that out there. This 1 plus theta cubed, that's going to be u. This 3 theta squared, let's move that over here so that we can see what we're going to do. Let's move that over there. We'll put a 1 up here. We've got 3 theta squared d theta. Noticing that that's all the same thing as du, we're going to replace that with a du. And then the last thing we're supposed to do is to substitute our upper and lower limits. So over here at our lower limit, this is when theta is equal to 0. And this is when theta equals 1. So when theta equals 0, then u, when theta equals 0, is going to be equal to 1 plus 0 to the 3rd power, which is just 1. And then when theta is equal to, what is that, 1? U, when theta equals 1, is going to be 1 plus 1 to the 3rd power, or just 2. So let's make those substitutions down over here. Instead of theta equals 0, we can say that u is equal to 1. And then instead of theta equals 1, we could change this to when theta equals 1, u is equal to 2. So that's all of our substitutions that we need to make. Everything is in terms of u now, and we don't ever have to go back to thetas. So let's go ahead and put this down over here and simplify. 1 over the square root of u, that's the same thing as u to the negative 1/2 power. And then if we integrate that, u to the negative 1 power, 1/2 plus 1 is, negative 1/2 plus 1 is 1/2. So this is 1/2, u to the 1/2 power. Let's put an equal sign. That's equal to u to the 1/2 power multiplied by 2 over 1. And this goes from u equals 1 all the way to u equals 2. Get rid of that intermediate step here. Now we just substitute. First thing we're going to substitute is u equals 2. Let's put a 2 here. And then we're going to substitute u equals 1. Let's put a 1 here. And yeah, that's a pretty good substitution. That's now we just have to simplify that. It's not a lot of simplification. That's just 2 square root 2 minus 2. I suppose if we wanted to go extra, we could factor out the 2 and say that's the same thing as 2 multiplied by the square root of 2 minus 1. But I don't think you're going to have to go that far with that. Yeah. Okay, that is question 21. Let's take a look at question 22. Okay, we're slowly getting into more difficult terrain here. I'm looking at that one, and there's no u substitution, which will be sufficient for this. I can imagine letting u be 2x, and if u is 2x, sorry, if u is x squared, my du is 2x, and that's not going to work here because 2x is inside the sine function. No real simplification to be done there. So since there's no u substitution, there's no real trig substitution either I can make. I suppose I could try the double angle formula for sine. But that's just 2 sine x cosine x. That's not really going to help us very much, since we still have the problem of having an algebraic function multiplied by a trig function. So that is pretty much grounds for me to use integral by parts. So we can do this a couple different ways, and I suppose I should entertain both of them. Let's go with the substitution, or not substitution, but the integral by parts step by step. So method 1 is that classic integral by parts. So we're going to start off with Liotte, and since this is a review video, I'm going to actually just write these down. Liotte, that's logarithmic functions, logarithm, and then I is inverse functions, specifically inverse trig functions, although, you know, inverse sines and inverse cosines also fall under that. A is algebraic functions, which is polynomials, and this is actually what we have here. We actually have an algebraic function. And then we have LIAT, trigonometric functions. And that's one that we have also. And then lastly, E is exponential functions. That's going to be our last choice. We don't have an exponential function here. Our algebraic function is x squared. And then our trig function is that sine of 2x. So that tells me that my choice of u should be whichever one of those two is higher up on the list, which should be x squared. So I'm going to say u is equal to x to the second power, which means necessarily that du is going to be equal to 2x dx. It's also going to tell me that dv is going to be equal to sine of 2x. Now this is a part where we have to be careful because we need to integrate. If dv is sine of 2x, then v is going to be 1/2 cosine of 2x. And I'm being reminded that if the antiderivative is a cofunction, then I'm going to need a negative sign there, because the derivative of a cofunction is a negative. Okay, let's put this together then. This is going to be equal to uv multiplied by v minus the integral of v du. All right, let's substitute what we have. We know u is x squared. We know v is negative 1/2 cosine 2x. So let's put that in for all of our v's. Looks like I'm running out of room a little bit here. And the last thing I need to substitute here is that du. du is 2x dx. And again, don't forget that dx part. It's actually really important. Can't integrate without it. Okay, I think that all fits now. Let's do a step of simplification. Starting with this first term, we could take this negative 1/2 out of that parenthesis. We can take the x squared out of this parenthesis. Don't need that. And then cosine 2x, of course, let's just leave it. No, I think we should take that out. Let's take that out. And great, that's simple. This negative over here, that simplifies with this negative here. It gives me a plus. This 1/2 and this 2, they multiply to make 1, so I can just get rid of both of them, or not get rid of them, but multiply them to get a 1. And, well, now we can get this cosine 2x, and let's put it here with this x dx. And then actually this whole thing doesn't need to be in parentheses at all. There we go. Simplified x cosine x dx. Now, this is problematic again because there's no u substitution to make. If you've done this a few times, then you realize that you're going to have to do this integral again. So let's switch colors here, and we'll switch, I think, to green and do this second little bit with green. Let's do another Liotte. All right, so this time around, I've got a algebraic function of x right here, and I have my trig function of cosine 2x right over here. And we can just, now we know what those are, we can use Liotte again. My choice of u will be x, and my choice of dv will be cosine 2x. So if du is x, then, if u is x, then du is going to be the same thing as dx, and that's very nice. If if dv is equal to cosine of 2x, then that means that v is going to be equal to 1/2 of sine 2x. Okay, I'm going to need some room here. Here's our last line of work, and we're going to replace this green expression. Let's put that in brackets just to help us with our negative signs. That's going to be u multiplied by v minus the integral of v multiplied by du. Right. Take that and let's put everything in here. We know all of our u's is the same thing as x, and my du is the same thing as dx, and my v is the same thing as 1/2 sine of 2x. Let's change this v into 1/2 sine 2x. Change this v into 1/2 sine 2x. And try to, there we go. That's better. Let's see. Let's simplify this. Take this, put it down over here. We'll do some simplification. Starting with this one right here, we've got 1/2 of, well, x multiplied by 1/2 sine 2x. That's the same thing as 1/2 x sine 2x. And then this integral back here, we can take that 1/2 out. We can take the, well, that's just 1/2 sine of 2x, really. There we are, simplified 1/2 sine 2x. And here we go again. We're going to simplify. Really, we just need to find the integral of 1/2 sine 2x. Let's see what we can do. We could take that this 1/2 right here, and we can move that outside the integral. Great. And then the antiderivative of sine 2x, that is the same thing as 1/2 cosine of 2x. And since it's a 1/2 cosine, or since the antiderivative is a cofunction, I can have to put a negative sign in there to preserve equality. And now that I've done with all of my antiderivatives, I'm going to put a plus c. These constants of integration have been building up all along. It's just that we're saving it to the very end to put the plus c all together. Okay, well, that is the end of the calculus part of this. The hard part now is to simplify this. Let's simplify. Okay, well, right off the bat, since we have a plus sign inside of our integral, or in front of this green bracket, we actually don't need the bracket anymore. We can just take each term out. Kind of like that. Let's see, we've got minus a negative, so we don't need a minus and negative. We can change that into a plus. And then what do we have? We have, yeah, 1/2 times 1/2, that's 1/4. Put that 1/4 there and get rid of this 1/2. And now we don't need the parentheses for this cosine. We can just take that cosine out of the parenthesis. Get rid of the parenthesis. And yeah, that's pretty good. If I divide out a negative 1/4, that puts parentheses around all of these. I'm going to divide out a negative 1/4. That means I just have to divide each of these coefficients by negative 1/4, which is the same thing as multiplying each of these coefficients by 4. Let's remember, dividing by 1/4 is just multiplying by 4. So negative 1/2 multiplied by negative 4 is a positive 2. Positive 1/2 divided by negative 1/4 is a negative 2. And then 1/4 divided by a negative 1/4 is a minus 1. Of course, you don't need that one, so we'll just go ahead and get rid of that. And that looks to be correct here. Which means I think we're done here. Last question for this video, number 23. I'm looking at our time, and this video has gone on a little bit long. Kind of natural since we've done some pretty difficult integration along here. This is also going to be a pretty difficult integration. Taking a look at this, we've got e to the negative 6x multiplied by cosine of x. Actually, I'm realizing that I had said that I was going to use the method number 2, the tabular method, in order to integrate question 22. So sorry to bring this one back again, but we are going to go through method 2, and as I promised. Okay, yeah, we do have an answer here, but we are going to demonstrate the method of using the table to do our integral by parts, hopefully easier. So let's get a table set up. Okay, here's our table set up. We're going to use the same method of getting of figuring out our u and our dv that we used up there. So hopefully it's not too much of a burden if we just use it. We've got an x squared here. And then over here for our dv, that's going to be, let's see, actually we probably should copy down our problem. Right over here. So I think we're going to have a sine. Yeah, sine of 2x right over here. Sine of 2x. Great. And of course, our product should be our integrand. Now that product is only a useful way of knowing when we stop. You're certainly free to just think of the product in your head. Not going to hurt anyone. So the derivative of u is 2x. The antiderivative of sine 2x, we've kind of gone over that already, so we can do that pretty quick. That's negative 1/2 cosine of 2x. And then this product, of course, is just going to be equal to, it's just x, negative x cosine of x. All right, so not any closer to solving this necessarily. So let's do another row of this table. The derivative of 2x is 2. The antiderivative of negative 1/2 cosine 2x, well, that's negative 1/4 sine of 2x. Multiplying that product, we get negative 1/2 sine 2x, which is great because we can integrate that. We're certainly welcome to stop here. But taking a look at our chart, I know that the derivative of 2 is 0, and that's much more attractive to me since I don't have to do any additional antiderivatives. Except for maybe this last one, the antiderivative of negative 1/4 sine 2x. That's a positive 1/8 cosine 2x. And the product is, of course, just 0. All right, since I've reached the 0 product, I can, integrate this with a table. All right, so the first thing which we're going to multiply together is going to be diagonal. So remember, we need to go diagonal here. We're going to multiply these two. And that's going to get me, let's see, equals negative 1/2 x squared cosine of 2x. Okay, that's our first one. Our second one is going to have to be negative because, well, we alternate between positives and negatives. So this next one, I'm going to multiply these two together. Let's multiply that, and we're going to say minus now. So minus, let's see, if we multiply those two together, we get 2 times 1/4 is 1/2 x sine of 2x. And I think I forgot my negative sign here. Yep. And then the last one we're going to do is we're going to add that next product. Let's see, what is that next product? It is this diagonal, 2 times 1/8. How much is 2 times 1/8? 2 times 1/8 is 1/4. We got a 1/4 cosine of 2x. And that does it, so we can put a plus c. I know I can stop here because I have the 0 in this very last cell of the table. This 0 tells me I can stop with the integration. I'm going to simplify this one time. Let's see. let's simplify that. We've got minus and a minus, so that's going to be plus. And of course, that doesn't need to be in the parenthesis anymore. And then this one over here, this doesn't need to be in the parenthesis anymore either. We can just take that out of the parenthesis. And this should be the same thing. And of course, that same process of factoring out that negative 1/4 will give me, I believe, the same result. This has been a pretty long video already. We'll see you on the next one.